Hey folks, I'm here to explain to you the differences for how to solve average velocity and instantaneous velocity. If you see at the top, v is equal to change in d over the change in t, this one right here, that is for velocity if we know the distances and the times. And we can solve the other one, velocity, if we know the acceleration and one particular time or unit of time. So I'm going to show you how we use v is equal to change in d over the change in t. This is a pretty straightforward one. It says a runner passes the 30.5 meter mark and then the 50.0 meter mark in an interval of 3 seconds. Assuming the runner is traveling in a straight line, not accelerating, what is the average speed of the runner? So this is a pretty straightforward one. We can, though, break it down into, we could say, well, the change in distance. We'll figure it out from subtracting 50 meters and 30.5 meters, and we're given the change in time as 3 seconds. So when we do that, we get 19.5 meters as the change between 30.5 and 50, and that time interval is still 3 seconds, and when you divide the two, you get 6.5 meters per second. Because we only know that the runner was traveling in 3 seconds, he could have been going faster or slower at any one point, but we only know 2 pieces of information for the distance, beginning distance, ending distance, and a 3-second interval. So the best we can come up with is we can average a speed of 6.5 meters per second. The next one, a cyclist traveling at an average speed. So in this case, we're actually given a velocity in a very straight and flat road. How far can the cyclist travel in 2.5 hours? So actually, if I were to circle things we're given v here, and we're given 2.5 hours, so that's a change in time. So we're actually trying to find d, but if you notice, d is not by itself. How do I get d by itself? I multiply each side by the change in t, and then we're left with change in t times v is equal to the change in d, or the change in the distance. And that's what we want to try to find, how far. So I'm going to plug in the information. So the change in time is 2.5 hours. And the velocity is 18 kilometers per 1 hour. And that is all equal to the change in d. And I'm going to cross out hours, cross out hours. I'm going to multiply across. When I multiply across, the only units I'm left with is kilometers, and 18 times 2.5 is 45 kilometers or kilometers. So that's the distance that we can travel in 2.5 hours on a bicycle going 18 kilometers per hour. And then the last one is a fairly straightforward one. It uses the equation v is equal to a times t, meaning velocity is equal to the acceleration times time. And velocity is what we want to try to find here. We're given acceleration. So v is equal to, here is the 15 kilometers, here's my acceleration, per hour over 1 second. So I'm just writing it a little differently, and here's the reason, because I'm going to multiply by time, and I'm going to multiply by 5 seconds, and I can put that over 1, and seconds are going to cross out, so I'm going to be left with 15 times 5, which is 75, and my units are going to be kilometers per hour. So my velocity, or my instantaneous velocity, at 5 seconds after an acceleration of 15 kilometers per hour every second is 75 kilometers per hour. Okay, that's how you solve those.